Welcome. So now we're going to use the box method to find area. Box method is useful to find the area of other polygons, including irregular polygons. So any kind of polygon you want to find the area of, you can find the area of it. Regular, irregular, doesn't matter. You can find the area of an octagon if you want. Right? So no matter what kind of polygon we're finding the area of, using the box method, our steps are the same. We're going to enclose the polygon in a box. That just means we're going to, these are in your notes by the way, draw a rectangle around the polygon. Very important, underline this in your notes, the vertices of the polygon must be on the box. Step number 2, you're going to find the area of the rectangle you drew. A little reminder there, formula for area of a rectangle is just the length of the base times the height. Third, you're going to find the area of the triangles that comprise the area between the rectangle you drew and the polygon you're trying to find the area of. You're going to subtract those out. So as a little reminder, area of a triangle is the same as the area of a rectangle, except it's 1/2 base times height. Make that a little bit neater. There we go. So the area of your polygon is just the area of the rectangle minus the area of the triangles. So let's take a look at this box method in action. And we're going to find the area of this particular polygon. Right, that's pretty irregular. This point here is at -3, 3. This point here is at -8 to -1. This point here is at -2, -2. And this person here, or this vertex here is at 2, 0. So let's box in our polygon. When we're boxing it in, very important to note that your rectangle is going to be comprised of vertical and horizontal lines only. That's what makes this easy to calculate. So rectangle is comprised of horizontal and vertical lines only. Right, so you just start at any polygon, any vertex. All right, so I'm going to start here. This is my farthest one out. That's going to represent the edge of the box. So the farthest one out is going to be the edge of the box. Notice I'm going to draw that. Well, I'm trying to draw a straight line there. Only between this point and this point, because that's going to be the edges. Right, so now I draw a horizontal line where the lowest point there of our polygon is. That's got to be a vertex on your rectangle there. It's got to intersect the rectangle there, and that's going to represent your lowest, the lower extreme of your rectangle. Notice I stopped here because I have a point. I can only draw a horizontal and vertical line, so I'm going to draw a vertical line here. I'm going to stop because I need to end my box. There's our box, right? So we'll find the area of the rectangle. Right, so this side here, right, so the farthest end here is -8 on the x and 2 on the x, right, so that's this side here, that's 10. This side here, let's draw that in, right, it's going from -2 there, the lower end on the y, and 3 is the upper value on the y. So this is 5. So the area of our rectangle, I'm going to put A and rectangle, is just going to be 10 times 5, and that would be 50 units squared. I'll put units squared. All right, so now third, we're going to find the area of the triangles. Notice we have some triangles. We have a triangle here. 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 And, oops, can't even read that 4 there. And, maybe I won't circle those. Those triangles represent the space between your rectangle that you've just found the area of and the polygon which you'd like to find the area of. There. All right, so let's find the area of all of these rectangles. All right, so I'll draw them I'll write in green, I guess, here. All right, so here, did I say area of the rectangles, area of the triangles? All right, so notice these triangles here, they are all rectangles. Right triangles. The triangles here are right triangles. Just a little tired, it's late. I don't know if you can see the time on my computer screen. That is PM, notice. All right, so and you should, actually I don't know if this one's in your notes, but you should write this down anyway. This was a good one, this should have really been in your notes. All right, so to find the area of right triangles, super easy. Easiest triangle of all. It's going to be the area equals 1/2. The base and height of a right triangle are the 2 legs. All right, so that's always what we're going to use when we're finding the area. All right, so now we need to find the area of all those triangles. All right, so we've got area of triangle 1. All right, so I labeled that triangle 1 there. All right, so from here, 1, 2, 3, 4, and then coming across here, 1, 2, 3, 4, 5. All right, so the base of my triangle is 4, the height is 5, or vice versa if you want to call the 4 the height and the 5 the base, it doesn't really matter. All right, so area of triangle 1 is just going to be 1/2 times 4 times 5. Half of 20 is 10. All right, so that triangle has an area of 10 units squared. Then we'll find the area of triangle 2. So we got the 1/2 there because it's a triangle. All right, so base here 1, 2. And my height 1, 2, 3, 4, 5. So the area of that second rectangle is going to be 1/2 times 2 times 5. All right, so half of 10. Oops, what did I put the? Oh, you know, I'm thinking of looking at the side of the rectangle there. Let me double check that area of triangle 2. Yeah, I'm looking at the 5 on the rectangle. All right, so the height there, 1, 2, was that 5? Yeah, that one is 5. Okay. Just want to make sure I didn't write down anything wrong. Got a lot of numbers there crammed in. And 1, oh, sorry, this one is 3. I knew something wasn't right. My base there is 3. Put the wrong number in. There we go. So the area of triangle 2 is going to be 1/2 times 3 times 5. All right, so 3 times 5 is 15. Half of 15 is 7.5 units. Area triangle 3. I already got the 1/2 in there. All right, so triangle 3 there. All right, base is 2. Height 1, 2, let's see, 1, 2, looks like 4. Yeah. So the height of that triangle is 4. All right, so the area of triangle 3 is 1/2 times 2 times 4. Half of 2 is 1. 1 times 4 is 4 units squared. We only have one more triangle. Triangle 4 there. So a little skinny triangle. Its base there is 1. And the height 1, 2, 3, 4, 5, 6. So the area of triangle 4 is 1/2 times 1 times 6, which is 3 units. You only have one more step, and then you've got this all solved. So remember, you got to find the area. We're looking for the area of the polygon, right? So that's going to be the area of the polygon. It's just the area of the rectangle minus the area of the triangles. Right, so area of our polygon is just 50 minus, we'll just add up all those rectangles and subtract. So 10 plus 7.5 plus 4 plus 3. There we go. 17.5 plus 4 would be 21.5. Plus 3 is going to be 24.5. So our area, need to move up just a little bit. Yeah. And so the area is going to be 50 minus 24.5, and that's going to give us 25.5. I need a little bit more space. I don't know if I can move anything up. No, I'm just going to move my words. How about if I move this? There we go. Look at all those green circles. There we go. That'll give me enough space to write. Whoops. That's lost our title. Whoops. Don't move figure. All this trouble for just a teeny bit more space. Let me see if I can get that out. Well, it looks fine there. Oh, there we go. And there we go. All right, so 50 minus 24.5 is just 25.5 units squared. All right, so really not that complicated. My words will come up. All right, so it's just box it a figure, finding the area of a rectangle, find the areas of triangles, and subtract, and that's all there is to it. And you can find the area of any polygon you want. All right, so this problem's done. Let's do another one. I think it's like 4 of them on this one. Whoops, we got this page twice. Sometimes it just happens. All right, so we're going to take a look at this one. All right, we're going to find the perimeter and the area. A little reminder for the perimeter, find the length of diagonal lines. We use our distance formula. So distance formula is, oh, that's a little bit crooked. The difference in the x-coordinates squared plus the difference in the y-coordinates squared. All right, so the polygon with vertices, A at -3, -1, B at -3, 3, C at 2, 3, and D at 4, -1 is drawn in the coordinate plane. Figure is a trapezoid. Right, we're going to use the distance formula to find the length of CD. All right, so first of all, we're just finding the perimeter. The perimeter is just the length of AB. Right, AB right there, plus the length of BC, and these are actually our line segments, plus the length of CD, and plus the length of AD. All right, we actually have to use the distance formula to to find CD. All the other ones we could just take the difference in coordinates. Right? That's all we'd have to do. All right, so our perimeter, or we can even just count. This is an easy count. All right, so AB there. A here is at -3, -1. B is at -3, +3. If we were to take the difference, the distance between, because the x coordinates aren't changing, so let's just take a look at the difference in the y coordinates. All right, so if we were to take 3 minus a -1, that would be 3 plus 1, which is the absolute value of 4, which is just 4. BC, right? If their C is at 2, 3. The y coordinates aren't changing, just the x, so it's just the difference. So BC is -3 minus and 2. So that difference there is the absolute value of -5, but that's just 5. CD, we have to use a distance formula for. All right, so the length of CD. All right, so let's write D in here. So 4, -1. There we go. So let's use the distance formula to find the length of CD. All right, so that's going to be difference in the x coordinates. 2 minus 4 squared. Plus 3 minus a -1 squared. Oops. Two minus 4 is a -2. And then minus a negative, that's a plus. So that length is going to be square root of 4 plus 16. All right, so let's, whoa, just got caught in my cord. Fortunately, I did not pull out my microphone. All right, so let's simplify that. That's the square root of 20. That'll simplify. All right, so 2 times 10, right? Good factors of 20 there. You can break the 10. That would be 2 times 5. 1, 2 comes out. 1, 2 goes away. 5 stays in radical prison. So 2 square roots of 5. And then finally, the last length here, AD. All right, since the y coordinates aren't changing, difference in the x coordinates, -3 minus 4 is the absolute value of -7 or 7. So now let's add this together. All right, so 4 plus 5, 9 plus 7, it's going to be 16. Now if we wanted a decimal equivalent, we could get that to combine these two terms. Or we can leave it like that because they're not going to be, we can't add those together. One has a radical and one doesn't. So let's just leave our answer like that. 16 plus 2 square roots of 5. All right, so we have found the perimeter. Now let's find the, this one asks for area. Oh, we're just finding the perimeter on this one. We could box it in to find the area, since we are looking at area, and let's actually do that. All right, so we're going to box in our figure. This one actually is a pretty easy box, right? Because this is actually a vertical line, and you got to have these vertices on, just right here. So the area is the area of our box. There, the rectangle. We only have one triangle this time, minus the area of the triangle. And that'll give us the area of our polygon. All right, area of the rectangle. All right, so 1, 2, 3, 4, 5, 6, 7. And then the base height there, 1, 2, 3, 4. So the area of the rectangle, I'll put it over here, is just 4 times 7. Should be 28. All right, so now let's find the, I'm going to move this here. Let's find the area of our triangle. It's not even 2. All right, so leftover space between our box and the polygon right there. All right, base here is 2. 1, 2, 3, 4. Height is 4. So the area of the triangle is 1/2. 2 times 4. Which is just 4 units. And then our last step, the area of the polygon. That's going to be the area of the rectangle, which is 28 units squared, minus the area of our triangle there. And that's going to give us 24 units squared. And that's it. We're all done finding the area of this one. So we're going to take a break, and then in the next podcast, we're going to look at some more area and perimeter area using the box method, and also finding perimeter of our figures. All right, bye for now. See you in the next podcast.